A rational expression is a fraction. If f of x is a function, a 1 over f of x is a rational expression. Okay, so basically we're dealing with fractions involving variables. That's what we're all dealing with right now in this unit. Okay? And this is really, really good stuff. I've taught calculus for the last 3 years. I'm not doing it this year, but these are the types of skills you will need as you move forward in math, what we're doing in this unit. Okay, so I'm going to do a few examples here on the next board. Okay, examples are going to be x squared over x minus 4, x plus 2 minus 4 over x, and x squared plus 4x plus 4 all over x squared plus 2x divided by x plus 2. Okay, these are the sort of things we're going to be dealing with in this unit. Okay? Those are common, yeah, those are all separate. So those are 3 different examples. So these are 3 different things that are rational expressions, okay? So number 1 is x squared over x minus 4. Number 2 is x plus 2 minus 4 over x. And number 3 is x squared plus 4x plus 4 all over x squared plus 2x divided by x plus 2 divided by x. Easy for me to say. Okay, so we're going to say simplifying rational expressions is just the same as simplifying fractions. Sorry, I'm going to get rid of the writing here. We're almost done. Okay, we're going to factor the numerator and denominator. And cancel anything that's the same. Finally, a rational expression is undefined with the denominator equals zero. A rational expression is undefined with the denominator equals zero. Okay, this is a lot to take in. I'm going to get it out of the way. Let me leave that out to make sure it makes sense. It says, simplifying rational expressions is the same as simplifying fractions. We'll factor the numerator and denominator and cancel anything that is the same. A rational expression is undefined when the denominator equals 0. So just like in that previous example we did with the 1 over x, for the domain we said x cannot equal 0, because if x is 0, you have 1 over 0 and there's a problem. To show why 1 over 0 is a problem. No, it's not. We're short on time, so I won't show why 1 over 0 is a problem. But please, Andrew, remind me on Monday to show you why 1 over 0 is a problem, and we'll do an example of it. How'd the game go? You can get hit, did you? And you're still able to talk and stuff like that. So, good game, though? Anything touchdowns for you? You didn't throw any touchdowns?
Half the time people didn't know where I was.
You're the broken finger. I'm going to pause the video to answer that phone, hopefully. So we're going to do for our first example, we're going to say find, number one is going to say, find the restrictions on X. Okay, what the restrictions on X are values that will cause the equation to blow up. So what we're going to say is here, what value of X will cause there to be a problem? Yes. No. 2 is okay. So there's okay? Negative 2. Yeah. So basically you're treating this just like a root. Okay. So you're going to say X plus 2 can't be 0. Right? So X can't be negative 2. And that's going to be your restriction. Every single question we do from here till the end of time, you're going to have a restriction like that. Any question on that before I continue? Think of it like a root. Okay, so here we go. Okay, guys, okay, it's okay. Basically what we did there, we're thinking what values of X can you plug in this equation that are going to cause it to blow up? You don't want to have divided by 0, right? You were okay on that? If you plug a negative 2 into this, you'll get negative 2 over negative 2 plus 2, which is negative 2 over 0, which will cause a problem. So all this is saying us what values of X are going to cause us a problem.
How did you find that out right away?
What's that?
How did you find that?
So what I did was here, I said X plus 2 can't be 0, right? So I just took the denominator and set it not equal to 0. So it's like a root, but the opposite of a root. Okay, so X plus 2 can't equal 0, then move it across to algebra. X can't equal negative 2.
Yes,
Yes, and then that'll be example 2. Here, okay. Example 2. Yeah, for restrictions, yes. Not yet. Okay, let's go on a little bit bigger here. It says state restrictions. We're not going to worry about solving anything quite yet. We'll deal with graphing and all this stuff next week. Let's start off by stating restrictions. So you have to think here, what is going to cause a problem when the denominator equals 0, right? So if the denominator equals 0, there's going to be an issue. So my first line I'm just going to write here on the side. We'll learn how to do this quickly. I'm just going to say 5x can't be, 5x minus 3 can't be 0. Before I go any further, now's the time you raise your hand with questions. We're okay? Because, yeah, only denominator, because you can have like 0 over 2 is fine, that doesn't cause a problem. If it's 2 over 0, it definitely would. Yeah.
So it's not always the first step, you just say that it can equal 0?
Yeah.
And then you find what?
Yeah.
Plus
Yeah.
whatever equals 0.
Yeah. And I'm going to show you the quick way to do it in a sec. This is a super slow way, but we'll show the fast way. Okay. Julia, can you solve for X, please? Solve for X, go ahead.
5x is not equal to
Good.
x is not equal to
Let's say that your name is IMQB 2013. Sorry, you're in my line of vision. That's why I picked on you, okay? And luckily for Kylie, she's sitting behind you, so I can't see her ever. Although Kylie, I picked on 5 times yesterday because you weren't here. An instant way you can do this is how it's always going to work. It's going to be the negative of this number divided by that coefficient, always. So 3 over 5. That's how it's always going to work. If you take a look at this, the negative of this number is negative 2 divided by the coefficient 1 is going to be negative 2. That's how it's always going to work. Okay. I'm going to give you one more to try here, and then we'll move on to our real lesson. Example 3. Okay, solving a linear equation. No, it's not a lesson. Solving a linear equation is not a lesson. Okay. Sorry for kicking your feet there. Okay. Example 3 says state restrictions. Oh my God. Okay, here we go. So it says state restrictions. Okay, now that one, if I look at the denominator, even me as your math teacher, I giggled a little bit on the inside when I tried to talk about sugar and gas, okay? But for me, that looks frightening. How did we find, like, is this, as we said, this is sort of like a root, right? Like, that's what we're doing here, sort of like finding a root. How would you find the root of something messy like that? What do you do? Factor, excellent, okay? So, okay, for those who said no when I said factoring, every question, remember I said yesterday if you weren't here, football players, there's probably 50 factoring questions about the next test. Like literally, okay?
You said 40 years.
Okay, so here we go. How do we factor? Let's go here, please. How do we? Can we go here, please? How do we factor the denominator? Brooke, okay. Brooke, how do we factor the denominator? First step. Sounds good. Good. Now it says 3x plus 1. Good. All right, Madison, what's common between negative 9x and 18, please?
Negative 9.
Good. What's left inside the brackets?
1 minus 12x minus.
Yeah, 2. Good. All right, now hold on a sec. The reason it's not plus 2, hold on a sec. I hear somebody saying it's plus 2. Negative. All right, now we're happy because Madison is always right, and also because both brackets match up. Vanessa, what does the denominator turn into?
Bracket x squared.
Yeah.
Bracket.
Now, of course, hold on a sec, please. Just wait. Of course, when you see x squared minus 9, of course you want to jump all over that and change it to something else instantly. What does x squared minus 9 turn into? Go.
X.
Close? X. Take away 3 and x plus 3. Go. Next. So 3x plus 1. All over. X plus 3. X take away 3 and x take away 2. Okay, with that, so we're finally factored out. The reason we factored out was for zeros here, for problems. What will cause a problem now in the denominator? What values of x? So, okay, so I heard from 2 people. This one here is going to be x can't be negative 3, because negative 3 is going to cause a problem with this bracket. X can't be positive 3, because positive 3 will cause a problem with this bracket. And x can't be 2, because it will cause a problem with the right bracket. Yes? Yeah, so what I just did here was, I just factored, thank you for asking. This just was difference of squares, right? So it's like square root of x is x, square root of 9 is 3. So when you do difference of squares, one's a plus, one's a minus. Okay, this is deep. You guys can do this. Don't give up. If you hate factoring, I can't help you. Okay, this unit is all factoring, and a million factoring questions you take. Brooke. That was easy. Okay, I'm going to take a breather here right now and stop the video because it's probably 38 minutes long. And then I'm going to, you guys can, only 13.